Good day, Sir Arias. Good day, everyone. We are the Group 5 of Grade 10 Sapphire, and we are here to discuss the sample space and probability of simple events.
The Group 5 members are Horango Cassandra, Enopia Irish Claire, Cabato Lawrence Andrew, Cabona Jeremy, and Ferrer Jetro. My name is Irish Claire A. Enopia, and these are the two main topics: sample spaces and the three ways of utilizing a sample space, list diagrams, table diagrams, and tree diagrams, plus probability of simple events.
Sample spaces. The sample spaces of a random experiment is defined as the set of all possible outcomes of an experiment. In a random experiment, the outcomes, also known as sample points, cannot occur simultaneously. An event is a subset of a sample space of an experiment, i.e., a set of sample points. All the possible outcomes of one or more events. Useful way to look at multiple probability outcomes. Three ways of utilizing sample spaces: list diagram, table diagram, and tree diagram as shown below.
Example number 1. When two dice are thrown together, we will get 36 pairs of possible outcomes. Each face of the first die can fall with all the 6 faces of the second die. As there are 6 by 6 possible pairs, it becomes 36 outcomes. The 36 outcomes pairs are written as. Example number 2. Construct a simple space that describes all three children families according to the gender of the children with respect to birth order. Clearly, there are many outcomes, and when we try to list all of them, it could be difficult to be sure that we have found them all unless we proceed systematically. Probability of simple events. An event that has a single point of the simple space is known as a simple event in probability. A simple event is one outcome or a collection of outcomes. The probability of an event is a ratio that compares the number of favorable outcomes to the number of possible outcomes.
Example number 1. A spinner with the looks of the picture at the right will be spinned once. Find the probability of getting the following. Probability of getting the letter C is equal to 2 over 7, since among the 7 parts, 2 of them contains the letter C. To get the percentage of the probability, divide 2 by 7 multiplied by 100 and get 28.5 and so on. Round it off and get 29% out of 100%. Next, getting the probability of the arrow stopping at either C or B is equal to 4 over 7, since there are 2 letter B's and 2 letter C's. Therefore, you have to add them and get 4 out of 7 possible outcomes. Again, divide 4 by 7, multiply by 100, and get 57%. Lastly, getting the probability of getting the color green out of the spinner, and which is 1 out of 7. Divide them, multiply by 100, and get 14%. Now for example number 2. A bag contains 7 red marbles and 5 blue ones. Solve for the following: probability of getting a red marble and probability of getting a blue marble. Probability of getting a red marble is 7 out of 12, since there are 7 red marbles and there are 12 marbles all in all. Get its percentage by dividing 7 by 12 and get 58%. Complementarily, the probability of getting a blue marble is 42%. Add both 58 and 42 and you'll get 100% of getting any marble.
Additional informations. Event is a subset of the sample space of an experiment set of sample points. Disjoint events. Two mutually exclusive events have no common outcomes. The occurrence of one precludes the occurrence of the other. Union. The union of two events is the set of all outcomes that are in either one or both of the two events. intersection of two events. Also known as the joint event is the set of all outcomes that are in both events. And lastly, certain, null, and complement of an event. A certain event consists of all outcomes and thus always occurs. A null event contains no outcomes and thus never occurs. The complement of an event contains all outcomes not included in the event. And that's all. Thank you for listening. If you all have any question, please don't hesitate to ask any of our group members.